naming Diyos. Maraming salamat po sa buhay at lakas na aming taglay, sa liwanag ng kaisipan at sa pagkakataong maipagpatuloy ang pag-aaral ng mga kabataan. Gabayan mo po ang bawat isa sa amin. Anuman ang bahagi na aming gagampanan, naway maging maayos at matagumpay ang pagtuturo at pag-aaral na aming gagawin sa araw na ito. Patawarin mo po kami sa aming mga pagkulang at pagkakasala. At sa aming paggawa, ikaw po ang aming makasama. Amen.
Good morning, parents, teachers, and learners. Welcome to Valenzuela Live. We are now in week 6 of quarter 4. Our topic for today is hypothesis testing about the population proportion. At the end of this lesson, you are expected to solve problems involving test of hypothesis on the population proportion, which means you can compute for the test statistic value and draw conclusion about the population proportion based on the test statistic value and the rejection region. Before we begin with the lesson proper, let us have a review of the 4 possible combinations of decisions and truth values of the null hypothesis. In the figure, row 1 shows null hypothesis is true. The second row shows null hypothesis is false. Column 1 shows reject null hypothesis, while column 2 shows do not reject null hypothesis. The intersections and rows of columns reveal the 4 possible combinations, 2 of which are correct, and the other 2 show type 1 and type 2 errors. Let us find out if you can identify the type of error in the following situations. Activity 1 is, what is your type? React hard for a type 1 error, which means that the null hypothesis is true, yet the decision is reject the null hypothesis. React like for type 2 error, where the null hypothesis is false, yet the decision is do not reject the null hypothesis. Are you ready? Let us have number 1. A man insists that he is 5 feet 10 inches tall, when in fact, his height is 5 feet 8 inches. React hard if it's type 1 error, or react like if it's type 2 error. Timer starts now. Time's up. The correct answer is A hard, because it's a type 1 error. Did you answer correctly? Great. Let's have number 2. A student allows his classmates to copy his answers during a test. He knew that it is a form of cheating, and it is a wrong deed. React hard if it's a type 1 error, or react like if it's a type 2 error. Timer starts now. Time is up. The correct answer is, okay, it's a type 2 error. You know that cheating is in any form is dishonesty and should not be tolerated. Do you agree? Okay, let's have number 3. Despite the risk, Cassandra applied as a domestic helper in Kuwait through an unregistered recruitment agency. React hard if it's a type 1 error, or react like if it's a type 2 error. Timer starts now. Time is up. The correct answer is, of course, it's like a type 2 error. Usually, an unregistered recruitment agency does not have the complete documents to secure the employment of workers abroad. It's really risky on the part of the overseas worker. Let us have number 4. A teenager says that her black curly hair is not kinky. Instead, she says it's afro-textured. React hard if it's a type 1 error. Or react like if it's a type 2 error. Timer starts now. Time is up. The correct answer is yes, it's a heart, a type 1 error. In the Western world during the 15th and 16th century, a man or woman with curly or afro-textured hair has historically been treated with disdain. Their heads would be shaved in effort to erase their culture. Nowadays, afro-textured hair is part of hair fashion. In fact, the 2018 movie Black Panther showcased a variety of creative natural hairstyles for both men and women. Can you now distinguish a type 1 error from a type 2 error? That's a wow. Let's go now to the lesson proper, which is hypothesis testing about population proportion. In the previous lessons, you have learned how to formulate null and alternative hypothesis for population mean. We identify critical values, compute test statistic, make decisions, and state conclusions based on the results. In this lesson, you will understand the concept of hypothesis testing about a population proportion, the procedure, and steps in doing so. The procedure here is almost similar to what we did when we dealt with sample mean and population mean. The sampling distribution of proportion approximately follows a standardized normal distribution. The test statistic for proportion, p sub 0, is given as follows. Z is equal to p hat minus p sub 0 over the square root of p sub 0 times q sub 0 divided by n, where p hat is equal to x over n. Now, p hat is the sample proportion, x is the number of successes, n is the sample size. Now, p sub 0 is the hypothesized population proportion, and we can find q sub 0 by subtracting p sub 0 from 1. Note that p sub 0 is approximately normal for n times p sub 0 greater than 5 and n times q sub 0 greater than 5. Let us have now the first example. The ABM Coffee Company claims that 20% or more of the coffee drinkers in Pinalagan, Malinta prefer their brand, the Ang Barako Mo Coffee. To test the claim, a group of CNHS grade 11 students conducted a survey, and this is what they found out. Out of the 500 randomly selected residents, 95 indicated ABM coffee is the reason why they wake up in the morning. Can we believe the claim? Is the claim true? Let's go to step 1. This is to formulate the null and alternative hypothesis. The proportion of residents in Pinalagan that prefer the ABM coffee is 20% or more. So we can represent p sub 0 greater than or equal to 0.20. That would be our null hypothesis. Now, the alternative hypothesis would be the opposite, which is p sub 0 less than 0.20. Note that we are using the symbol less than in our alternative hypothesis because we hope to prove that the obtained sample value 95 is significantly lesser than 100. That is the 20% of 500. Step 2, we have to find the critical value. Since less than is used in the alternative hypothesis, then one-tailed or the left-tailed test will be used using an alpha equal to 0.05. In the table of z-test, we know that a left-tailed test and an alpha of 0.05 will have a critical value equal to negative 1.645. go now to step 3. We have to verify. Is n times p sub 0 greater than 5? To do that, we have to multiply n, which is 500, times 0.20, and we will get 100. And 100 is greater than 5. So the question, is n times p sub 0 greater than 5, would be answered by yes. Next question, is n times q sub 0 greater than or equal to 5? Then we have to do the following computation. N times q sub 0 would be equal to 500 times 0.80, and that is equal to 400. And again, we see that 400 is greater than 5. So the question would be answered again by yes. Take note that our q sub 0 is taken from the difference of 1 minus p sub 0, which means you have 1 minus 0.20, so that you got the 0.80. And since both questions are answered by yes, and it is implied that we may now use the z-test for population proportion. Go now to step 4. In step 4, we compute test statistic using the z-test for population proportion. The formula is z equal to p hat minus p sub 0 divided by the square root of p sub 0 times q sub 0 divided by n. Now, p hat is equal to x over n. Our x is equal to 95 divided by n, which is 500. So we will get a p hat of 0.19. Plugging this value to our formula, we will have z equal to 0.19 minus 0.20 divided by the square root of 0.20 times 0.80 divided by 500. Performing all these operations, we will get a z equal to negative 0.5590. So the next step would be to set up the rejection region and the critical value. Since we are using the left-tail test, then the critical value z equal to negative 1.645 will be in the left side or leftmost part of the distribution. And the computed z, which is equal to negative 0.5590, will be found outside the red region, which means we can now make our decision and conclusion. So for the left-tail test, if the computed value is less than or equal to the critical value, then we will have to reject the null hypothesis. Otherwise, we do not reject the null hypothesis. Since negative 0.5590 is greater than negative 1.645, then we do not reject the null hypothesis. Which means our conclusion would be there is no significant difference between the sample proportion and the hypothesized population proportion. It is now safe to say that 20% or more of Pinalagad residents prefer ABM coffee. Okay, so let's go to number 2. A local government official claims that only up to 25% of all public school students in the city own an electric gadget that can be used for distance learning like cell phone, tablet, or laptop. To test the claim, a group of grade 11 statistics students made a survey and found out that out of 1,000 randomly selected students, 275 indicated that they are ready for online learning. Can we infer from the data that the local officials is true to his claim? Let us use alpha equal to 0.05. Let's go to step 1. Let's formulate the null and alternative hypothesis. The null hypothesis will be coming from the proportion of students who own an electronic gadget, and it is only up to 25%, which means our p sub 0 would be less than or equal to 0.25. The alternative hypothesis would now be p sub 0 greater than 0.25. This is because the proportion of students who own an electronic gadget is more than 25%. Note that we are using the symbol greater than in our alternative hypothesis because we are hoping to show that the obtained sample, which is 275, is significantly greater than 250. That is 25% of 1,000. Step 2. We are now going to find the critical value. Since greater than is in the alternative hypothesis, then this is an indication that we are going to use the one-tailed right-tailed test. And our alpha again is 0.05. So, looking at the table again, the critical value for a right-tailed test and an alpha equal to 0.05 would be 1.645. Let's go to step 3. We will verify again if n times p sub 0 is greater than 5 and n times q sub 0 is greater than 5. From the computation, n times p sub 0, we have 1,000 times 0.25, which is equal to 250. And 250 is greater than 5. So the question again will be answered by yes. For question number 2, n times q sub 0 is equal to 1,000 times 0.75, which is equal to 750. And 750 is greater than 5. Therefore, our question again is answerable by yes. Since both are answered by yes, then this is an indication that we can now use the z-test for population proportion. Okay, let's go to step 4. We'll be computing for the test statistic using the z-test proportion formula. Again, the formula is z is equal to p hat minus p sub 0 all over the square root of p sub 0 times q sub 0 over n. For p hat, which is equal to x over n, we will be using 275 divided by 1,000. And that is equal to 0.275. So we will be plugging in that to our formula. And q sub 0 would be from 1 minus p sub 0, which means you will have a q of sub 0 equal to 0.75. So again, we will be plugging this to our formula so that we will now have z is equal to 0.275 minus 0.25 divided by the square root of 0.25 times 0.75 over 1,000, and you will get the value of z equal to 1.8257. So let us now set up the rejection region and the critical value that we got. Okay, since we are using the right-tailed test, then our critical value z equal to positive 1.645 and z equal to 1.8257, which is our computed value. We can now compare that z equal to 1.8257 is found inside the rejection region, which is the red shaded portion. Which means, step 6, we can now state our decision and make our conclusion. For the right-tailed test, if the computed value is greater than or equal to the critical value, then we have to reject the null hypothesis. Otherwise, we do not reject the null hypothesis. So from our computation, since 1.8257 is greater than 1.645, then our decision is to reject the null hypothesis. So, our conclusion would be there is a significant difference between the sample proportion and the hypothesized population proportion. It is safe to say that the proportion of students who own an electronic gadget in this city is more than 25%. Can you still follow? Okay. Shall we proceed with example number 3? Okay, this is the question. According to a study, 9% of the children ages 4 to 10 in a certain region are underweight. The city mayor wants to know whether this claim applies to his city. So he asked the health department head to randomly sample 1,200 children. 21 of the children in his study were found to be underweight. Is the city's proportion significantly equivalent to that of the region's proportion? Let us use alpha equal to 0.05 to find it out. So our step 1 again is to formulate the null and alternative hypothesis. From the sentence, according to a study, 9% of the children ages 4 to 10 in a certain region are underweight, we can now have a null hypothesis, which is p sub 0 equal to 0.09. And of course, the alternative hypothesis would be its opposite, which is p sub 0 is not equal to 0.09. Step 2, we are now going to find the critical value. Since not equal is in the alternative hypothesis, this means that we are going to use the two-tailed test. So from our table again, the critical value for a two-tailed test and an alpha equal to 0.05 would give us positive negative 1.96. If z is less than negative 1.96 or z is greater than 1.96, then the null hypothesis would be rejected. Let's now go to step 3. We have to verify the question, is n times p sub 0 greater than 5? And is n times q sub 0 greater than 5? So this would be answered by yes if we can compute for n times p sub 0, which is equal to 200 times 0.09, and that is equal to 18. And 18 is indeed greater than 5. N times q sub 0, which is equal to 200 times 0.91, and that is equal to 182, which is greater than 5. Thus, both is answered by yes, and that is an indication that we will be using the z-test for proportion. Let's now proceed with step 4. We are to compute for a test statistic using the z-test for proportion with the formula z equal to p hat minus p sub 0 all over the square root of p sub 0 times q sub 0 over n. Now, a while ago, we saw the formula of p hat, which is equal to x over n. Computing that, we will have 21 divided by 200, and that would be equal to 0.105. So, our z would be now equal to 0.105 minus 0.09 all over the square root of 0.09 times 0.91 divided by 200. Performing these operations, you may use your calculators, of course. You will get a z equal to 0.7412. So, after that, we now have to set up the rejection region and the critical value. Since we know that we are going to use the two-tailed test, then the critical values would be on the left and right of the distribution. The left critical value would be z equal to negative 1.96, and the right critical value would be z equal to positive 1.96. Now the computed value, z equal to 0.7412, will be found less than z equal to 1.96, which means it is outside the rejection region. Therefore, Proceeding to step 6, which is to state your decision and make conclusion. For the two-tailed test, we know that since 0.7412 is less than 1.96, then our decision is do not reject the null hypothesis. So, this would give us the conclusion that statistical evidence supports the claim that the city's proportion is the same as the region's proportion of children's ages 4 to 10 who are underweight. So, are you ready to find out how much you have learned today? Let's go to activity number 2. It's entitled, What Have You Learned? In number 1, you are going to arrange the steps in hypothesis testing using the population proportion. Here are the steps in random order. A. Compute the test statistic value. B. Find the critical value. C. Set up the rejection region and the critical value. D. Formulate the null and alternative hypothesis. E. Verify if the test to be used is Z population proportion. And F. State your decision and make conclusion. So your task is to arrange this randomly ordered steps in hypothesis testing, and you will be reacting hard if your arrangement follows A, C, E, F, B, D. Or react like if it's in the arrangement D, B, E, A, C, F. Timer starts now. Time's up. What's your answer? Yes, the answer is like. The correct arrangement for hypothesis testing is D, B, E, A, C, F. Did you get it? In number 2, in a study, the null hypothesis P sub 0 is equal to 0.06, since 3 out of 50 college graduates are affected by career mismatch. Then what would be the appropriate null alternative hypothesis? Is it a hard, which is a P sub 0 not equal to 0.06, or a like, which is a P sub 0 greater than 0.06? Time starts now. Time's up. What's your answer? Yes, it's a hard. A P sub 0 not equal to 0.06. Number 3, which is the appropriate test to use if the null hypothesis is P less than or equal to 0.45 and the alternative hypothesis is P greater than 45. Is it a hard, which is for the right tail test, or a like for the left tail test? Timer starts now. Time's up. The answer is yes, it's the right tail test. Okay, let's proceed with number 4. The critical value for a left tail test with alpha equal to 0.01 is Z equal to negative 2.33. If the computed test value Z is equal to negative 1.58, then what would be the correct decision? Is it a hard, which is to reject the null hypothesis, or a like, which is do not reject the null hypothesis? Time starts now. Time's up. The answer is yes, we do not reject the null hypothesis. Let's go to number 5. A researcher tested a company's claim that 97% of cough-afflicted people will be cured after 3 days of taking their product, which is a cough medicine. Using two-tailed test with alpha equal to 0.05 and the z-value, which is equal to negative 3.76, the researcher decided to reject the null hypothesis. What do you think is the best conclusion for this situation? Is it a hard, which means the statistical evidence is enough to support the company's claim, or a like, which is the company's claim is statistically inaccurate? Time starts now. Time is up. Your answer would be, of course, it's the like sign because the company's claim is statistically inaccurate. Did you get the perfect score? Wow, that is very nice. By the way, do you have any questions that you would like to ask in order to clarify some things? You may write it in the comment box. Okay, here is one. Is z-test the only test statistic that we can use in hypothesis testing? Of course, z-test is not the only test statistic that we can use. In the previous lessons, you have encountered t-test. We have introduced that to you and discussed it. There is also a chi-square and ANOVA test, which are also the common ones. Any more questions? If there are no more questions, then let me leave you with a task to work on. It is found on page 9 of Quarter 4 Month 10 Statistics and Probability module. This would be your learner's task, okay? So, this has been your statistics and probability teacher for today. Thank you for tuning in. Happy learning and stay safe, everyone. Goodbye.